Alright, so this podcast is on the second type of variation, which is inverse variation. Okay? So, once again, this is the formula. It's y equals k divided by x. Okay, and the location is important. The k is on the top and the x is on the bottom. It's being divided by the x. Okay? And so, once again, the way we read this officially is y varies inversely with x. Okay? Once again, our k is still the constant. It's how it's changing. Okay? So it's the exact opposite of direct. Remember last time we talked about direct variation changes the same way. But inverse, so for example, if my y variable goes up, inverse means that'll make the x go down. Or if the y goes down, it'll make the x go up. It's changing the opposite way. Okay? So like a real life example of that may be something like, let's say we're driving in a car and we're taking a trip, right? Let's say y is how much we're driving. So the more miles we drive, as the miles go up, if our x is the gas in the car, what happens to the gas? It goes down, right? So the more you drive, the less gas you have left. That would be like inverse variation. Okay? Or let's say you had some food, right? Let's say we had a pizza. So if we have our pizza, the more people that we have, if our y goes up, the more people that we share our pizza with, x goes down. That means the less pizza we each get because the pieces get smaller. Okay, so that's like a real life example of inverse. Now here's what's important about the graph. The graph is going to be very different. Inverse variation graphs are not linear. They're not a straight line. They'll be a curved line, and they'll get really close to the axis but never touch it. The other difference is, remember, direct variation has to go through the origin. These do not touch the origin. Okay? Alright, so just like before, let's go through some of these solving problems using the inverse variation formula. Alright, so now here the directions tell us, determine whether each equation represents an inverse variation. So now we're just practicing identifying. If it does, identify the constant. So once again, in order for us to really look at it, we have to solve for y. Y equals 3 over x, or 3 divided by x. Y is by itself. I'm ready to look at this. And this matches the formula. So yes, this is inverse. And the constant is 3. The constant is what's on top. Okay? Number 2, we have xy equals 2. Now I can't say yes or no yet. I got to get y by itself. So we're going to do the opposite and get rid of the x by dividing it. That's gone. Now my equation is y equals 2 over x. That is my y equals k over x. Yes, again, that's inverse, and now my constant is 2. Okay? Now number 3, y equals 4 over x plus 2. That looks really close. I got my y equals k over x, but there's no plus or minus after. So no, that makes it wrong. If it didn't have the plus 2, it'd be good. Alright, and then last one, y equals 2x. Y is by itself. I don't have to do anything. But that's not quite the same. It's got to be k on top divided by x. This is times. This is no. This is really direct, what you just did last video. Okay? Alright, so let's go to the next page here. Alright, so let's do a little bit of practice. Okay? So here the directions say, suppose y varies inversely with x. Okay? That means, because they're telling you it's inverse, that means you're going to use the k divided by x formula. Okay? And then once you do that, it then tells you to write an inverse equation that relates the x and y. And that's going to be with the k. The k is how they're related. And then we're going to solve. Okay? So number 5 says y equals -1 and x equals -2. So if I plug in my numbers, y equals k over x. Okay, so it's important you plug in the numbers in the right place. The x is on the bottom. Okay, so now I need to solve for k. So k divided by 2, the opposite of that would be times 2 on both sides, right? K is by itself. 2 times -1 would be -2. So our k is -2. So now I'm going to keep it. But now instead of y equals k over x, I'm going to plug in -2 for the k, x on the bottom. And then I'm going to use this new formula to solve for x. So here it says find x when y equals 1. So y is 1 equals negative 2 over x. I'm trying to find x. Alright, now this equation looks pretty weird because we've talked about getting rid of the bottom number, but here the bottom is the x. So I think one of the best ways to do this is to take this left number, which is 1, and make it a fraction. Okay? If I move this again. So if I take that negative 1 that is on the left side, and if I make it a fraction by throwing it over 1, remember this from chapter 2, if I have a fraction and a fraction, what I can do here is I can just cross multiply. Okay, sorry, that's kind of messy now. So now it's x times 1 is x, and then 1 times negative 2 is negative 2. So that's my missing x value. Okay? And if you think about it, look what happened here. Remember we said inverse variation changes the opposite way. So look at my y. Y was negative 1 at first, and then it's positive 1. That means it went up from negative 1 to positive 1. That means the x should go down, and look, it went from positive 2 to negative 2. So those change the opposite way, and that's what direct inverse variation is. Okay? Alright, let's try the next one here. So, number 6 says y equals 3 when x is negative 2. So I'm going to plug it into the inverse variation formula. Y is 3 equals k I don't know over x is negative 2. Solving for k, opposite of dividing by negative 2 is multiplying by negative 2. And I'm going to do that on both sides. K is by itself. Negative 2 times 3 is negative 6. That's our new k. So let's make the real equation now. Y equals negative 6 over x. Okay, this is the equation that shows how they're relating. Okay, and now I'm going to use that to find x when y is 5. So 5y is the y equals negative 6 over x. Okay, I want the x to stay, so I'm not trying to get rid of it. So let's make this out a fraction. And then let's once again, because I have a fraction on two sides, cross multiply. 5 times x is 5x. Negative 6 times 1 equals negative 6 on the other side. And then I just got to divide both sides by 5. And then x equals, final answer, negative 6 over 5. And sometimes you will get a fraction as an answer. Okay? Alright, last one we'll do together here. So now number 7 says y equals 4 when x equals 2. So let's plug it in. Y equals, and y is 4, k over x, and x is 2. So to get k by itself, we're going to do times 2 on both sides. K equals 2 times 4, which is 8. So now that we have our 8, we'll write the new equation, y equals 8 over x. That's changing with the constant of 8. And now that we have that, we're going to find x when y equals 4. So let's plug it in here. The y is 4 equals 8 over x. We're trying to find x. So let's throw this over 1 so we can cross multiply. So 4 times x is 4x equals 8 times 1 is 8. Divide both sides by 4. Final answer, x equals 2. Okay? Alright, so pause the podcast. Try numbers 8, 9, and 10 on your own and check your answers. Okay? Alright, so for these last three problems, here's the k, the new equation with the k, and the missing variable. Alright, so take a look at these three. Now, on 9 and 10, hopefully you're reading carefully. They switched it up on you. All the first four problems we were finding x. These two ones were finding y, so you should have been plugging that number into the x. Alright, so those are those three. Number 8, the x was a fraction, and once again, that's okay. Okay? Alright, last three problems. Just practicing identifying the graphs. Okay, so numbers 11, 12, and 13 are different graphs, and it says identify each as either direct variation, inverse variation, or it could be neither. Okay, so think about what they should look like in the rules. Okay, number 11, look at that, it's a straight line, right? So straight line, that means it's not inverse, but look carefully. Is it direct though? Remember, the one rule about direct is it has to go through the origin, and this line does not. So number 11 is neither direct or inverse. Okay? Number 12 is that curved line. Hopefully remember the curved line is inverse. And 13, straight line. And look, it does go through the origin. Therefore, that one is direct. Alright, so that's pretty much for that section.